Welcome to Advent of Tessellations 2025. My name is Madonna Yoder, and you're joining hundreds of folders around the world on this 25-day journey into the infinite world of repeating patterns folded from a single sheet of paper. You'll discover many different twists in this challenge, building up to advanced patterns with flagstone motifs of trapezoid twists. Welcome to day 7 of Advent of Tess, in which we're folding this little pattern named citrus slices. So we're using 24 grid divisions on a hexagon. This is something you can learn in the welcome video to the series, which you can see if you're on YouTube, beginning of the playlist, linked in the bottom, or at training.gatheringfolds.com/advent. Once you sign up, you'll see that welcome video top of the page. So we're going to start in the center with a closed hexagon twist. And to start in the center with a closed hexagon twist, we start with a mountain fold heading out to the corner on the right and a valley fold one space above that. We're going to make the same pleat on each of the 6 sides of the paper, letting the center of the paper stay raised up into the air. Notice that I'm turning my paper to get from one pleat to the next, and I'm keeping it down on the table. I can also allow the tension in the paper to be released by smoothing out underneath. And I'm really letting the table do a lot of the work of holding these pleats in place. So whenever I fold the first twist on the paper, unless there's some really extreme circumstances going on, I'm always going to let the table help me with my folding. I want to let these plates flatten out until there are 2 grid spaces. So here, 2 grid spaces left, still sticking up in the air. With that in place, I am going to tap the top, hold that pressed in just gently, grab 3 sides. So I'm grabbing 3 sides. I'm going to squeeze gently as I do a sharp twist around, and that unfortunately is what often happens. But notice I can smooth that out, and I can double check that all of my valley folds underneath are still folded on the grid lines. And that smooths out the closed hexagon twist. Now we're going to flip the paper over. It doesn't matter what way we flip because all of the 6 sides are exactly identical. Then, just like we did in day 5, we are going to fold open triangle twists on the pleats coming from the closed hexagon at tube pleat spacing. But unlike what we did before, we'll look at a different ordering and we'll put a different twist at the pleat overlaps. That's going to be our closed rhombus twist, and it's going to be on this same side of the paper. So I'll start by marking my valley fold one space out from this folded mountain. My mountain fold goes one spacing further out, and my third mountain for the triangle twist outlines 1 grid triangle in mountain folds. So I'll set up the pleat that makes a tube and find my third pleat around this triangle, remembering to erase the extension of the first pleat that continues past the triangle. Once this is in place, I'll press to squash. This time, unlike day 5, I'm going to turn and work in a counterclockwise direction. There's all kinds of ways to describe the rotation of paper, but basically I'm going away from the tube and to the larger space between parallel pleats. I'm going to find the same triangle twist again with the valley fold one space out from the folded mountain, also hitting this pleat one space out from the closed hexagon hole. And my mountain fold is going to be one space away from the valley, and this will be an open triangle, so we're outlining one grid triangle. I'm going to let these two pleats overlap while I set up my triangle twist, and I will press to squash. So what we've seen before is that with the hexagon in the center, two triangles will overlap at a new hexagon twist, but that's not what we're doing today. Today we're turning that into a closed rhombus twist. So before I open this up, I'm going to mark two things on this paper. I'm going to mark a straight line along the mountain fold of the second triangle twist. And I'm marking this little bracket, little angle bracket, in the last grid division along this line before it hits the mountain fold of the next pleat. These are going to be landmarks. When we open up, we will have another special grid triangle on the other side of this marked mountain fold. And when we open the pleat below, we're going to keep the marked mountain fold going straight, and the other direction of mountain fold is going to jump to the far side of these triangles marked with the angle brackets. I call this the central diamond of the rhombus twist. I can emphasize both of those mountain folds, and they're going to lay down on valley folds that are above on the right-hand side. So this is a right-handed twist, which makes sense because the hexagon was right-handed. These triangles next to it were left-handed. Now this rhombus is next to the left-handed triangles, so it must be right-handed. So the two features of the rhombus twist to look for are the through line, the mountain fold that continues straight through from one side to the other, and the diagonals, the mountain folds that jump over one grid spacing as you go from one side of the twist to the other. I should say those are the characteristic spacings of the closed rhombus twist, but we actually won't be seeing any open rhombus twists this year, so we'll stick with that as the description of the rhombus. From here, it's kind of similar actually, this in one, out one, to the open hexagon twist, and so this twist squashes the same way, namely, you press from the top. And then smooth out. So let's see that one more time. I'm going to rotate to this thicker spacing between parallel pleats. I'm going to have a valley fold one space away from this folded mountain. I'm going to have a mountain fold one space further than that. This will form an open triangle twist and a pleat overlap. The through line of the rhombus twist is going to come from this second triangle. As I open up the pleat overlap, I can enforce that mountain fold continues through straight. Notice before I force that, pop this up, that mountain fold was continuing one space lower. So we're going to force it up to the top, and the valley fold is going to be above that fold if I hold it in my right hand. The valley is going to be above the mountain, rather. Then this diagonal needs to jump one spacing so that the two mountains are closest together and the valleys are outside of the mountains. So the valley is down here, the mountain has to jump that way. We've got our mountain fold and then the valley on the far side. And press to squash. Once more, a little bit faster without drawing, so you can see what it looks like if you're not drawing on the paper. I'm putting in the valley fold and the mountain for my second pleat of the open triangle twist. I'm finding my third pleat by outlining the target grid triangle with a mountain fold and putting the valley on the appropriate side so I can squash this new triangle twist. Then I know the through line of the rhombus is coming from the newest triangle. So when I open the pleat overlap, I'm going to make this grid line a mountain the whole way out. The valleys on either side of the twist are going to be on opposite sides of the mountain. And my diagonals are going to be one grid spacing apart with, again, valleys on opposite sides of the mountains on either side of the twist. Then I can press from the top to squash. There is another good way to find the reference for this rhombus twist, and that would involve going the opposite direction around the paper. So now that we've seen a couple of repeats of going in this direction, I want to show you what it would look like to go the other direction and the benefits and challenges that that holds. So if I'm going this direction, I can easily see the reference mountain for my tube pleat. And I can set this up, putting in the new open triangle twist and causing a pleat overlap up above. You might be saying, hey, that pleat overlap is going to be harder to open on this side of the paper. That's why we did the other way first. And we're going to press to squash. The benefit of using this unfriendly pleat overlap is that when you pop it open, that mountain fold is already in the right place. And so is this mountain up here. You just have to be very careful, if I put that back, to not disturb these extensions of mountain folds. I don't recommend clips in this situation because the folds have to be flexible. You could clip just the mountain, and that could hold them in place. And then you put the valleys on the opposite side of those mountain folds, and boom, there's your rhombus twist. So that is easier in some sense, where you're not moving the mountain folds around, but you do have a more difficult overlap to open. For our final triangle, and we're going to have a rhombus on either side, so we're going to get to see both of those one more time. I'm going to have my valley fold coming down one space out from the parallel folded mountain, my mountain fold one space away, and this will be an open triangle twist. So my third direction of mountain is going to outline the target grid triangle in there. Once again, we really want to pay attention to erasing the extension of the pleat from the hexagon that goes past the triangle. This is something that I see a lot in beginning tessellation folders, where you want to try and hold on to anything that looks like it should have been there, but sometimes it should have been, and now it's not needed anymore. So listening to the paper can be tricky until you learn exactly what you're trying to listen for. And press to squash. Our easy overlap to open is down below. We have our through line coming from the triangle that we just put in. One side of our central diamond is sitting on top there. And when we open up, we need to move both the mountain coming out, which was going down here, need to move that up 1 grid spacing, and this mountain coming over needs to move up 1 grid spacing as well to get all of the pleats for that rhombus twist. And then, like I mentioned earlier, on opposite sides of the twist, the valley folds will be on opposite sides of the mountain folds. Which, if you consider taking one of these twists and rotating it halfway around, you should expect it to exactly match up. Then, with the overlap that's less friendly in terms of the mechanics of opening it, we are able to say, okay, here's my mountain fold down here. I'm going to push from the back and pop this point forward. I'm keeping all of my mountain folds, and I'm just putting the valleys on the other side for these two that aren't connected to twists. And that's the adjustment to get into the closed rhombus. From there, I can press from the top to squash, and that actually concludes my model. That gets you all the way to citrus slices. This is one of the faster patterns that we're doing this year because there's only 13 twists. 1 hexagon, 6 triangles, 6 rhombi, 13 twists in total, and there's your pattern. So let's take a quick look at the backlighting and at some ways of continuing the pattern. So one of the things that I mentioned is if you take the rhombus and you flip it halfway around, you see the same thing. Well, you can do that with this whole pattern. Take the rhombus and treat it as what's called a position of twofold rotational symmetry. All that means is when you flip it halfway around, it looks the same. Likewise, these hexagons are in positions of 6-fold rotational symmetry. When you turn it 1/6 of the way around, it looks the same. Whenever you have 6-fold rotational symmetry, you also have positions of 2-fold and 3-fold rotational symmetry. In this particular case, the position of 3-fold symmetry is in a blank part of the grid, but it doesn't have to be. You could choose to ignore the symmetry in the rhombus and put some triangles in between things and get a pattern that continues as well. You can also put even more stuff between the repeats of these chunks that are triangle twists and also some rhombus twists. And actually this guy with the rhombus right between 2 open triangles is precisely what you see on the back side of the base pattern. I just thought it was amusing to put it on both sides. So all 3 of these ways of repeating these patterns can be found in the Advent of Tess 2025 ebook. This is a digital file that you can download. You pay $25 depending on exactly where you get it. It's at gatheringfolds.com, origamiusa.org, and origami-shop.com. And you can see all of these patterns drawn out in crease pattern form on 64 grid divisions. You can also see some more tiling diagrams. There's a lot to explore when it comes to these patterns and how they repeat. So that's all for today's pattern. Tomorrow, we're going to be using rhombus twists again. Actually, we're going to be using rhombus twists for quite a while. And this time we're doing rhombus twists around an open hexagon twist. with more rhombus twists on the back and resolving with some triangle twists on the front. So this pattern has a lot more twists than today's. If I count correctly, it's got 1, 2, 3, 4, 5 distinct positions that have 6 copies and 1 in the center, so that makes 31 twists total. It's not actually the pattern that has the most twists. Tomorrow, the day after this, actually has 36, but there's plenty going on here, and we'll get to practice both the left-handed and right-handed forms of the closed rhombus. So happy folding, everyone, and I'll see you back here tomorrow.